Hi, welcome to myprojectbazaar.com. In this video will lead us to complete demo of an ontology-enabled framework for a geospatial problem-solving environment under the domain of data mining. In this project, an ontology-enabled framework for a geospatial problem-solving environment that allows collaboration among web service providers, domain experts, and solution seekers to semantically discover and use the geographic information service to solve a target class of geospatial problems. The framework contains ontology provide the knowledge basis for domain experts to formalize geospatial semantics and conceptually model workflow of geospatial problems for semantic references and interference. An ontology-enabled catalog that provides an interface for web services providers to annotate GI services using formal semantics for semantic discoveries. A web portal that supplies an interface for solution seekers to submit their geospatial problems and evaluate the discovered GI services. And an ontology engine that parses the problems and performance semantics inference to discover the required GI services based on annotated semantics. And conceptualize process. To validate the applicability of the framework, a prototype was implemented using an earthquake as an example. This paper concludes by not only highlighting that framework which may lay a foundation for fully integrating ontologies and GI services to solve geospatial problems, but also identifying future geospatial problem solving environment. In this process, first we need to collect the data from domain experts to providing the answers for the queries from users. For this, domain experts data in the form of ontologies that may having that format of RDF or OWL. For this one, we need to analyze the ontologies format like RDF. Then we need to predict the properties of that RDF like object properties, data type properties. After predicting the properties, we need to computing that classes and subclasses relationships between that ontology attributes. After predicting the properties and classes, we need to computing that n-triple conversion. In this n-triple conversion will contains the subject-object predicate classification. After this prediction, we need to store the data to server for the parsing format. Then we need to get that question from that user side for answering support. After getting that question, this question may contain that any kind of question type and the ontology part as well as reference part. This may be parsed by using that query parser. After we parsing that query, we need to compute the rules. These rules will help us to providing the better results relevant to that user query. After predicting the rules, we need to applying that ontology prediction. Then we are applying the conceptual workflow for creating the results. After this, we have to evaluate the results by using that. Next, we are going to see the complete demo of ontology-enabled framework for geospatial problem-solving environment. For this one, first we need to run the home.java file. In this page will contains purely that user queries. For this one, first we need to choose the geographical data set. In this data set will contain that set of elements which was representing the geo-land positions. For this one, next we need to predict that ontology part. This is the AutoCAD portion. In this page, we can able to add that any kind of properties because our data set contains the state, city, river, high point, low point, road, lake properties. we can able to add these properties. For example, I have to adding that set property. This is the property structure. For this one, first I have to entering that, then I have to clicking that RDF properties, then I have to providing the next. This is the content I'm going to be add, then I have to writing the data set, then I can click that view that file. For this file we can able to adding that property into our data set. After we computing this, we move to that home page and we have to predicting that RDF classes in our selected database. After this selection of RDF classes, we need to computing that RDF properties. This properties will showing the number of properties will showing the database. Next we need to computing the data type properties. This data type properties will having that properties like city, state, lake, mountain, high points, river and road and their links of that ontologies. After this we need to predicting that object properties. In the previous page we have to getting that 28 properties. For this one, the 28 properties will be divided into two parts, 11 data type properties and 17 object properties. Next we need to parsing that subject. For the parsing of the subject will showing that basic structure of each attributes. For example, state containing that name, abbreviation name, then state, population, area and borders. This will showing that what kind of data will pass through there. After this we have to computing that each data's parsing. Next we storing this content to that SQL file and we can able to viewing that parsing contents. Now our data set will be passed into some set of arguments that will showing that this kind of data. It will be showing for all kind of attributes. Next we move to that user query page. In this query page user can able to register. For this one, first I have to entering my system IP. After this I am moving to that user IP page and providing the password. Then click that verification. Now I am logged in successfully. In this page we will use to posting our queries. For this query page we can able to post our queries. This will be added into database depending upon query and their time. Then next you have to providing that query and we have to applying that query parser to predicting that question type. Now the question type will be predicted as where and that keyword will be Great Salt Lake. Okay. After this we have to computing that query part, ontology part as well as reference part. Here there is no reference part, so the ontology part will taken as the reference part. After this computation we need to computing that class prediction. So it will showing that our predicted data was for Great Salt Lake, so it was in the class of lake. Then next we have to computing that RDF properties. It will be in that lake contains properties and the sub properties are lake, their area and their state. After we predicting this we can get the relevant items for this lakes and we have to computing that precision values. So this precision will showing that how much precision value we get in and their accuracy value plus their timing scenario plus precisions. This will showing that processing of improvement from our existing to proposed one. From this one we have to developing that new proposed one for providing the better results for our user query in that ontological geospatial environment. Thanks for watching.